In section 4.3, we are solving systems of linear equations by addition. We're going to use the addition method to solve a system of linear equations. And I have a four-step process for solving a system of equation by using the elimination by addition method. First, you want to set up the equations with the x's, y's, and equal signs all lined up in vertical columns. Then we multiply both sides of either or both equations to get opposite terms. You either want to get opposite x terms or opposite y terms. The third step is to add the equations from step 2 together and solve for the remaining variable. And our final step is to substitute the result we get from step 3 into one of the original equations to solve for the other variable. For our first example, we see our system of equations, x plus y equals 5 and x minus y is equal to 11. Now, lucky for us, the first step is already done for us. The first step is to set up the equations with the x's, the y's, and the z's all lined up. So notice we have the x's all lined up in the same column, the y's and the equal signs are all lined up. The second step is already done for us as well because we have opposite terms. In this case, we do have opposite y terms. The x's are the same, x and x. The y's are opposite. We have a positive y and a negative y, or a plus y and a minus y. So we can jump to step number 3, where we are adding the equations from step 2 together. When we add like we're adding up a column. We take the first column, x plus x, and an x plus an x gives us 2x, where the plus y and the minus y, these are opposites, so when you add them, you get 0. So we have 2x plus 0, or just 2x on the left side of the equation, is equal to 16. And then by dividing both sides by 2, we find that x is equal to 8. Now we are ready to go to step number 4. And in step number 4, we substitute the result from step 3 into one of the original equations to solve for the other variable. So let's look at so again, step 1 and 2 was already done. This was step number 3. And now step number 4, we take one of the original equations. Let's start with the first one, x plus y is equal to 5. And I'm going to replace the x that we found in step number 3 with 8. So 8 plus y is equal to 5. And then by subtracting 8 from both sides of the equation, we get y is equal to negative 3. So the solution to the system of equations is x comma y, or 8 comma negative 3. And as always, you do want to check your work by plugging those values into the original equation. The first equation, x plus y, would be 8 plus negative 3. That does equal 5. And x minus y would be 8 minus a negative 3, which is equal to 11. So we know that 8 negative 3 is a solution to that system of equations, and we did that by using the elimination by addition method. In our second equation, we see that the first step is already done for us. We have the x terms lined up, the y terms lined up, and the equal signs are all lined up. In addition, we can see that we have step number 2 is already completed because we want to get opposite terms, either opposite x terms or opposite y terms. Now, negative x and negative 6x are not opposites, but plus 4y and minus 4y, these are opposites. So we have step 2 already completed. Let's move on to step 3, where we're adding these two equations together. A negative x minus 6x would give us a minus 7x, and the plus 4y and the minus 4y give us 0. And then we add together 28 minus 56. Or 28 plus a negative 56, which would give us negative 28. Now we can divide both sides of this equation by negative 7 to get x is equal to 4. So that our first two steps were done for us in the setup. Step 1 and 2 already done for us. Step number 3 is to add those equations and solve for the variable. And then our fourth step here is to plug this answer from step 3 into one of the original equations. I'm going to do the first equation, which is negative x plus 4y equals 28. I'm going to replace the x in that equation with 4 and then solve by adding 4 to both sides. And then we get 4y is equal to 32. And then we can divide both sides by 4 to get y is equal to 8. So that means our solution to this system of equations, the x is 4 and the y is 8. Again, we want to check this in the original equations. So negative x plus 4y would be negative 4 plus 4 times 8. Negative 4 plus 32 does equal 28. And in the second equation, negative 6 times 4, that's negative 24, minus 4 times 8, 32. Negative 24 minus 32 does give you negative 56. So we know that 4, 8 is a solution to that system of equations. All right, let's look at example C. See if step number 1 is done for us. Do we have the equations all lined up? So we have the x's are lined up, the y's are lined up, the equal signs are lined up. But step number 2 is not done for us. We don't have opposite terms. Notice we have x and minus 7x. Those are not opposites. And 5y and 4y, those are not opposites. So we're going to have to multiply both sides of either or both equations so that we end up with opposite terms. So looking at the x terms, since the x terms I'm considering here are a positive x and a negative 7x, I want them to be opposites. And one way to do that is to multiply the multiply the first equation by 7. So if we were to multiply x by 7, we would get a positive 7x, and we already have that negative 7x. So in order to make those opposites, we're going to multiply the entire first equation by 7. That means we're going to multiply the left side of the equation and the right side of the equation by 7. And when we do that, we get 7x. We're actually going to distribute that 7x plus 35y is equal to 49 times 7, which is equal to 343. And then the second equation already has a negative 7x, so I'm just going to rewrite the second equation so that everything is lined up. Notice the x's, y's, and the equal signs are lined up. Now we can use the, go to the third step, which is where we can add these equations together. We're going to add up the x terms and we get 0. That always happens when you have opposite terms. And then the y terms, we're adding up 35y plus 4y, and that'll give us 39y is equal to 343 minus 31, or 312. Now we're going to solve this step by dividing both sides by 39 to get y is equal to 8. So we have step number 1 was done for us. Everything was lined up. Step number 2, we had to multiply by 7 so that we ended up with opposite terms. And then step number 3 is to add those equations together and solve it to get one of the variables. Now on to step number 4 is to take that answer from step 3 and plug it into one of the original equations. Let's use the first original equation, x plus 5y is equal to 49, where I'm going to replace the y in that equation with 8. And then I get x plus 40 is equal to 49. And then we know by subtracting 40 from both sides, we can find that x is equal to 9. So our solution can be written as the ordered pair 9, 8. And as always, we want to check our answers by going back to the original equations, not the equations that we're using in step number 2, but the actual original equations. Let's look at the first one. Is 9 plus 5y, where y is 8. 9 plus 40 equal to 49. It works. That is a solution to the first equation. And let's plug that into the second equation as well. Negative 7 times x, where x is 9. That's negative 63. Plus 4 times 8, 32. Negative 63 plus 32. That will give us negative 31. So we know that 9, 8 is a solution to that system of equations. Now let's look at example D. We have x plus 3y equals 2 and 4x plus 2y equals 18. Notice that our first step is already done for us. We have the x's lined up, the y's lined up, and the equal signs lined up. So we're in good shape there. The second step is to multiply both sides of either or both equations to get opposite terms. Well, here we could either get opposite x terms or opposite y terms. And it would be nice perhaps to get the opposite x terms. So in getting those opposite x terms, if one of my terms is x and the other one is 4x, I want to keep the 4x in the second equation, but I want in the first equation to have the opposite of that. So I would like that first equation to have a negative 4x. In order to do that, I would have to multiply the whole first equation, both the left side and the right side, by negative 4. So when you do that, you distribute, and the result, when you distribute that negative 4, you get negative 4x minus 12y on the left side of the equation, and don't forget the right side, 2 times negative 4 is negative 8. And then the second equation I'm just going to write again so that everything is lined up. And notice again I have the x's lined up, the y's lined up, and the equal signs lined up, and I have the opposite x terms. Now I'm ready to go to step number 3, where I add those equations together. So I add negative 4x and positive 4x is 0. Those are opposites. Those will always equal 0. And negative 12y plus 2y is negative 10y. And negative 8 plus 18 is positive 10. Now, by dividing both sides by negative 10, I get y is equal to negative 1. That's our step number 3. We solve for that variable. Now we plug that answer back into one of the original equations. I'll plug it back into the first original equation, x plus 3y is equal to 2, and then I'm going to replace that y with negative 1. So we get x plus 3 times negative 1 is equal to 2, or x minus 3 is equal to 2. By adding 3 to both sides, I get x is equal to 5. So my solution to this system of equations is 5, negative 1. And as always, we want to check our solution by plugging that back into the original equation, x plus 3y equals 2, where x is equal to 5 plus 3 times negative 1. That would be 5 minus 3 does equal 2. It does work. It is a solution in the first equation, but we also want to make sure it's a solution in the second equation. So it's going to be 4x, or 4 times 5, which is 20, plus 2 times y, 2 times negative 1, that would be negative 2. So 20 plus a negative 2 does equal 18. So we know that 5, negative 1 is a solution to that system of equations. So in example E, we have our system of equations where the x's, y's, and equal signs are lined up, but we don't have opposite terms. We don't have opposite x terms or opposite y terms. So I'm going to go ahead and look at the x terms and determine a way that we can make opposites. So when you do that, you're going to take, we're going to take the negative 2x and the positive 5x. We want to find the least common multiple of 2 and 5, and that's 10. So we would like one of these terms to be, say, a negative 10x, and the other term to be a positive 10x. And in order to do that, we would have to multiply negative 2x by a positive 5 to give us a negative 10x, and we would have to multiply 5x times 2 to give us a positive 10x. So we're going to multiply the whole first equation by a positive 5 on the left side and the right side, and we're going to multiply the whole second equation by a 2 on the left side and the right side. We're going to write those equations. Don't forget to distribute distribute what we multiplied by. And for the first equation, we can now write it as 5 times negative 2x, which is negative 10x, 5 times negative 7y, that's minus 35y, equals on the right side negative 6 times 5, which is negative 30. And then the second equation, I distribute that 2 to get 2 times 5x, which is 10x, and 2 times negative 3y, which is minus 6y, or negative 6y. And then on the right side, negative 26 times 2 is negative 52. Now I'm ready to do the third step where we add those equations together. We have the x's lined up, the y's, and the equal signs, and we have the opposite x terms. So by adding those together, negative 10x and a positive 10x is 0. And then a negative 35y minus 6y, we get a negative 41y. And on the right side, we have a negative 82. So to solve this for y, we're going to divide both sides by a negative 41, and we see that y is equal to 2. So that's our third step. We're going to plug that answer back into one of the original equations, and we'll start off with, say, the first original equation, negative 2x minus 7y is equal to negative 6. Make sure you plug it back into the original equation. And then we're going to plug in that y equals 2. So we get negative 2x minus 7 times 2 is equal to negative 6. Simplify that to get negative 2x minus 14 equals negative 6. We can add 14 to both sides to get negative 2x is equal to 8. And then by dividing both sides by negative 2, we can see that x is equal to negative 4. So our solution to this system of equations, written as an ordered pair x comma y, is negative 4 comma 2. And we want to check that in the original equation, negative 4, 2. The original first equation, negative 2 times a negative 4, that would be a positive 8, minus 7 times 2, that does equal negative 6. And in the second equation, 5 times negative 4 is negative 20, minus 3 times 2, or 3 times y, which is minus 6, that does give us negative 26. So we know that negative 4, 2 is the solution to that system of equations. Okay, let's continue with example F. 5x plus 8y equals 1 and 2x plus 3y equals 2. We see the x's, the y's, and the equal signs are already lined up, but we don't have the opposite terms. I have 5x and 2x for the x's, 8y and 3y for the y's. Since we got opposite x's last time, let's go ahead and try this one with getting opposite y terms. And in order to do that, you want to find the least common multiple of 8y and 3y. Least common multiple of 8 and 3 is 24. So we want one of these to be a positive 24y, and we want one of them to be a negative 24y. So in order to get this 8y to equal a 24y, we would have to multiply the whole first equation by 3 on both the left side and the right side. And then in the second equation, to make that y term equal a negative 24y, we would have to multiply the whole second equation by negative 8. So when you do that, when we distribute, we have 3 times 5y is 15y. I'm sorry, 15x. My bad, excuse me. So that's 15x, and then 3 times 8y is that 24y, and on the right side we get 3. In the second equation, we're multiplying the whole equation by negative 8. Negative 8 times 2x is negative 16x, and negative 8 times 3y is that negative 24y. That's great, we have the opposites, and on the right side we have negative 16. Now we can add those two equations together, that third step in the addition method. 15x minus 16x, we get a negative 1x, or just negative x, plus 24 and minus 24y, these are opposites. We're going to get that equal to 3 minus 16, or negative 13. When we divide both sides by a negative 1, we see that x is equal to 13. Now we're going to take that answer and plug it back into one of the original equations. If we use the first one, 5x plus 8y equals 1, and by plugging in the x equals 13. Now when we substitute that in, we get 5 times 13 plus 8y is equal to 1. Now 5 times 13 is 65, plus 8y is equal to 1. We're going to subtract 65 from both sides to get 8y is equal to, I should have put a 5 there, so negative 64. And then when we divide by 8 on both sides, we get y is equal to negative 8. So our solution to the system of equations is x equals 13 and y equals negative 8. As an ordered pair, we write that as 13 comma negative 8. We check that back into the original equation. So we have 5 times 13. What is 5 times 13 is 65. And 65 plus 8 times negative 8 is a negative 64. That does equal 1. And then 2 times 13 is 26. Plus 3 times that negative 8 is a negative 24. That does equal 2. So we know that 13 negative 8 is a solution to that system of equations. Let's look at example G. Negative x minus 2y equals negative 4 and 5x plus 10y is equal to 8. Notice the x, y's, and equals are all lined up. And let's say we want to get opposite x terms. So look at our terms. We have a negative x. It would be nice if that were a negative 5x. And the other term is 5x. So these would make it opposite. In order to get that first equation to have a negative 5x, we're going to multiply the whole first equation by a positive 5 on the left side and the right side. So when you distribute that positive 5 times negative x is negative 5x. 5 times minus 2y, that's going to give us minus 10y, is equal to the right side, negative 4 times 5 is negative 20. The second equation already has a positive 5x, so we're just going to write that underneath. We have the x's, y's, and equals lined up. Now we can use the addition part of that method. We get the negative 5x and the positive 5x, we get 0. And negative 10y and a positive 10y, we also get 0. So on the left side of this equation, we get 0 because it ends up that the x's and y's are both opposite when you multiply the first equation by 5. On the right side of the equation, negative 20 plus 8, we get negative 12. Now we see that here is a problem. 0 equals negative 12 is what shows up in this step, but that is certainly not true. 0 does not equal negative 12. So we say this system of equations has no solution. And if you were to graph those two linear equations, those lines would be parallel. Let's move on to example H. 4x minus 6y equals 1 and 20x minus 30y equals 3. Let's work to get opposite x terms. We have 4x and 20x. So we can find the least common multiple of 4x and 20. The least common multiple would be 20. So it would be nice to have the first term as a negative 20x and leave the second equation with a positive 20x. In order to make that first equation have a negative 20x term, we would have to multiply the whole first equation by negative 5. And we want to do the same thing to the right side of the equation. Now when we multiply negative 5 times 4x, we get negative 20x. And negative 5 times negative 6y is plus 30y equals a negative 5 on the right side. And the second equation we're going to leave. 20x minus 30y is equal to 3. Now we have opposite x's. In fact, we also have opposite y's. When you add those together, negative 20x and positive 20x is 0, and 30y and minus 30y is equal to 0. So we have a 0 on the left side and a negative 2 on the right side. So unfortunately, this is also a contradiction. 0 definitely does not equal negative 2. So we can say this also has no solution. And if you were to graph those lines would be parallel. Now be careful here if you're using a graphing calculator to check some of these problems, that these two lines, when you graph them in H, they are so close together that they look like they're the same line, but their y-intercepts are just slightly off. So be cautious if you're using a graphing calculator to check any of these. Now the next systems of equations, we've got some fractions in there. So it would be nice if we could get rid of those fractions or even decimals before using the multiplication addition algorithm. And in the first two equations of the first system, we see that there's a 3 in the denominator. So we would like to multiply both of those equations by 3 so that we can end up with terms that don't have any fractions in them. So it'll be a little bit easier to deal with. So we can multiply the whole first equation by 3 on both the left side and the right side. Whole second equation by 3 as well on the left side and the right side. And then when we distribute that 3, we get 9x plus 3 times a third is just 1y. 9x plus y is equal to 30. And in the second equation, 3 times 2x gives us 6x. And then 3 times 2/3 gives us 2y, and then 12. So now we have a system of equations without any fractions. Now let's see, we can see that the x terms are lined up, the y terms are lined up, and the equal signs are lined up. Now we want to get opposite terms, either opposite x's or opposite y's. And I want to look at these y terms, because if we make the first equation have a negative 2y and that second equation is already a positive 2y, then we're going to have those opposite y terms. And to get that first equation to have a negative 2y term in it, we want to multiply both sides by negative 2. When you do that and you distribute, negative 2 times 9x would give us negative 18x, and then negative 2 times y is at minus 2y, and on the right side, 30 times negative 2 is negative 60. And the second equation we're going to keep as 6x plus 2y equals 12. Now we can add those two equations together. We have negative 8x plus a 6x, that's negative 12x. The y's are opposite, so when adding those we get 0. And then we have negative 60 plus 12, and that is a negative 48. Now we can divide both sides by a negative 12, and we get x is equal to 4. Now we can plug that back into one of the original equations, and let's use the first one. 3x plus 1/3 of y, or 1/3 of 4, I'm sorry, 1/3 of y, equals 10. Notice I'm putting it back into the original equation, and then I'm going to get 3 times 4, which is 12. 12 plus 1/3 y is equal to 10. I'm going to subtract 12 from both sides. Let me move up over here. I get 1/3 y is equal to negative 2, and then by multiplying both sides by 3, I get y is equal to negative 6. So my solution to this system of equations is 4, negative 6. And of course we want to check our work by plugging it back into the original equation. We're going to plug 4 into x, so 3x would be 12. 3 times 4 is 12. And then 1/3 of y. 1/3 of negative 6 is negative 2. So 12 minus 2 does equal 10. And 2x in the second equation, 2 times 4 is 8, plus 2/3 of y, where y is equal to negative 6. So that's going to be plus a negative 4, does equal 4. So we know that 4, negative 6 is a solution to that system of equations. In this example, letter J, we have decimals, and it would be easier if these were integer coefficients, so without any decimals. And one way to do that is to multiply everything by 10, since each one of these numbers has only one digit after the decimal. So by multiplying the whole entire first equation by 10 and multiplying the whole entire second equation by 10, we'll end up with two equations without any decimals. When you multiply 10 times 3.5, that's going to be 35x. 10 times 0.3y is going to be plus 3y, and multiply on the right side to get negative 187. The second equation multiplied by 10, 10 times 0.7 is 7x. 10 times 0.9y is plus 9y, and then 10 times a negative 7.1 is negative 71. Now we end up with these two equations, the x's, y's, and equals are lined up, and we want to get opposite terms. I could either get opposite x terms or opposite y terms. Let's go ahead and get opposite x terms. In order to make, look at the least common multiple of 35 and 7, we would like, say, the first equation to stay with that 35x and the second equation to have a negative 35x. In order to make that second equation have a negative 35x, we would have to multiply the entire second equation by negative 5. When we distribute, we will get those opposite x terms. The first equation we're going to leave alone, so I'm going to write it one more time here. 35x plus 3y equals negative 187, and then the second equation distributing that negative 5 times 7x is negative 35x. Negative 5 times 9y is going to be minus 45y, and negative 7 times the negative 5, equals 355. I meant to say negative 71 times negative 5 there. Now we can add these equations together, and the x terms are opposites. The y terms, 3y minus 45y is a negative 42y, and the negative 187 plus 355 is 168. Now we can divide by negative 42, and we get y is equal to negative 4. Now we're going to plug this back into one of the original equations. I always like to plug it back into the original equation just in case I've made any kind of mistake here. I don't make more mistakes on top of that. So let's check that, and we're going to plug this y into one of the original equations. Let's use the first one, 3.5x plus 0.3 times y, but y is going to be negative 4, equals negative 18.7, and negative 4 times 0.3. We can simplify this equation. 3.5x minus 1.2 equals negative 18.7. I'm going to take that negative 18.7 and add 1.2 to both sides. So I get 3.5x is equal to negative 17.5. And then I'm going to divide both sides by 3.5 so that I end up with, let's see, x is equal to negative 5. All right, so my solution to the system of equations is negative 5, negative 4, and always you want to check that back into the original equation. 3.5 times negative 5 is negative 17.5 plus 0.3 times negative 4 is a negative 1.2, and that does equal the negative 18.7. And we're going to plug the solution back into the second equation. 0.7 times negative 5, that is negative 3.5, plus 0.9 times y, which is negative 4, is negative 3.6. So when you add those together, you do get the negative 7.1. So we know that negative 5, negative 4 is a solution to that system of equations. By multiplying the original equations by 10, we were able to get the equations without any decimals.